Hello everyone, my name is Saili Baburavarpe. Today I am going to present my topic data scaling and future scaling in deep learning. This topic is an important part of data processing and it helps deep learning model train efficiently and accurately. Introduction. In deep learning, input data often comes with different ranges. For example, one feature might represent age in a year, while another might represent salary in 1,000. If we feed such unstable data into a neural network, it can cause unstable gradient, training, and based learning. To solve this, we use data scaling, which makes all features fall within a similar range. This helps activation function and optimizer perform better, resulting in faster conversion and more accurate models. Here, example, when age is 20 to 60 and income 10,000 to 1 lakh are used together, income overshadow age. Scaling equalize their influence on the model's learning process. Here, diagram of future scaling and data scaling. Concept description. Now let's understand what data scaling and future scaling mean. Data scaling means adjusting the overall range of numerical values. For example, converting all data between 0 and 1. Future scaling means transforming each features individually so that all features contribute equally during model training. In short, scaling ensures that level large values features like income don't dominate smaller ones like age. It's small step but very important in deep learning pipeline. Let's see an example. First is a example of data scaling. Before scaling age equal to 18, 25, 14, 16, salary 10,000, 30,000, 80,000. After applying min-max scaling, age is 0.0, 0.16, 0.55 and 1.0. Salary is 0.0, 0.29 and 1.0. Now both futures are in the range of 0 to 1. This helps the neural network learn fairly from both futures instead of focusing only on the one with large number. Here, example of future scaling before height 150, 160, 170, 180. After standardization, here result is minus 1.5 minus 0.5 plus 0.5 plus 1.5. Mean equal to 0, standard equal to 1, balanced future impact. Next, working me- mechanism. How How do data scaling work? Here, how future scaling fits into a deep learning workflow. We first collect and clean data, then we analyze the future to check their range and outlier. Next, we select the appropriate scaling method like min-max or standardization. We apply the transformation to all features. Finally, we train the neural network with scaled input for stable gradient flow after faster conversation. This process ensures smooth optimization during training and better overall performance. Here, workflow of scaling. First first raw data, then data cleaning, then future scaling, then data learning model training and prediction and selected data. Here, challenges and limitations. Limitation of data and future scaling. Not all algorithms need scaling. Then min-max normalization is a high sensitive to outlier. Wrong scaling may destroy dis- distort the true data relationship. Then scaling parameters must be reused for unseen test data, otherwise results become inconsistent. Although scaling is helpful, it also has some challenges. If we use the wrong scaling method, it can harm performance. Scaling should be fit, fitted only on a training data. Otherwise, it may cause data leaked. For every large data set, scaling increase pre-processing time. And finally, not all models need scaling. Tree-based models like random forest or XGB boost work fine without it. Example, if scaling is fitted directly on train and test data, prediction result differ drastically. Here, summary. First, we see applications. Future scaling has many real-world applications, such as in deep learning models. It improves conversations and stability. It in image processing, pixel value are normalized for 0 to 1. In NLP, embedding vectors are scaled to equal length in financial and medical data. And it also improves algorithms like K-means, KNN, and TCA. To summarize, future scaling is an essentially pre-processing step that improves deep learning model training by keeping input data in balanced range. It helps achieve stable gradient, faster learning, and better accuracy. Future work includes adaptive scaling methods that automatically adjust ranges during training. Thank you. Thank you for listening.